This is Engineering versus Cosmology, a matter of perspective. This is my understanding of math, physics, and engineering, explaining every step of the way. Assuming the reader has at least an Algebra 2 level of education, most of this will be clear. In math terms, this is an Algebra 2 level equation. d of t equals 1/2 at squared plus v naught t plus d naught. This is a kinematic law of motion under constant acceleration in dynamics. Other laws are calculus derivatives of the first. V of t equals at plus v naught. A of t just equals a, because it's constant. There are simple algebraic equations requiring calculus 1 to calculate. Alternatively, they could be written in shorthand as A equals V prime, which is also equal to D double prime, or V could equal D prime. Also, each apostrophe represents the derivative with respect to time, d dt. A equals dv dt, which is equal to d dt over dt, which is equal to d squared of d over dt squared. V equals d over dt, or dd dt. The variables of the kinematic equation of motion of a free-moving rigid body are the following: constant acceleration a, velocity v, distance d, and time t. Choosing a reference point is important depending on what information is sought. Given some of these values, the other values may be calculated, especially if the acceleration is 0 and the initial distance is 0. Then we are left with d equals vt. In third grade, the velocity v was called a rate, r, so that kids like me that played in the dirt might pay attention to d equals rt, or easy as dirt, d rtt, distance equals rate times time. Let's say we view a light signal and read the distance and relative velocity of its source, d and v. The signal itself travels at the speed of light, c, with 0 acceleration. From the initial distance, we can now find the time t of the event at any distance, d. I have a little graphic, d naught, which is the source at time 0, and d of t is the distance at any time. So the distance at any time is equal to c times t plus d naught. D naught does not have to be 0. Where d naught is the starting distance of the signal. The equation describes the distance of a signal from its source according to time, with the origin at the source. In the reference frame being plotted on the graph on the last page, the observer is now at the origin rather than the source. So the equation changes slightly due to the change in reference frame. D of t and t are now both 0 at the origin, and what used to be the starting distance d naught is still the starting distance ds. I have a little graphic, d naught and ds. D naught is the observation point, ds is the distance of the source. What starting time s did the signal occur for it to reach the observer at the origin d naught equals 0. The equation turns out to be 0 equals c, the speed of light, times s, the starting time, plus the distance at the starting time. So that little equation shows us that the time is negative the distance divided by c. This is the calculated starting time s, and aside from the ds notation is basic algebra. Convert the distance d of t to time t. T equals negative d of t over c. We have three components: accepted data of d of t and v of t at a calculated starting time t of each signal source. Next, we focus on the acceleration of the signal source, not the signal source, relative to the observer at t equals 0, d of 0 equals 0, and v of 0 equals 0. That's the velocity at time 0, which is the origin at the data plot, the reference point. I have some ugly equations there. Acceleration equals dv dt, which is the same thing as v of t minus v naught over t minus 0. In that calculation, you can read that. This is the basic Algebra 1 form, the slope m of a line that follows the formula y equals mx plus b, or m equals y2 minus y1 over x2 minus x1. Y is v, x is t, m is a in this case. B equals v naught, which is 0. Therefore, v equals at plus v naught. That's one of those kinematic equations. The plot needs modernizing edits as follows. The vertical axis is velocity in kilometers per second, not kilometers as labeled. The horizontal axis is distance in megaparsecs, each parsec converting to about 3¼ light years. The extragalactic nebulae are now understood to be other galaxies. The best fit line in cosmology's equation v equals ht should be v equals at plus v naught. The horizontal axis needs to be converted to negative time, showing deceleration. The following plot is the 1929 data submitted by Edwin Hubble. So clearly we have a line going up. Vaguely straight, but not really. As an engineer, I criticize the cosmology interpretation of their data and hereby put theoretical physics to the task of undergoing an engineering review. Their analysis is incomplete, as this plot is not representing acceleration but deceleration. A conversion to time is required without forgetting the minus sign. The velocity increases over distance and falls over time. The future is in the opposite direction. This can be fixed. I am ready. Conclusion: the evidence shows me that the universe is not accelerating apart. There is no dark energy, nor was there a Big Bang. We may now free up resources devoted to these theories. There's more I understand about this data, including how the variations from the best fit line in the graph can tell us more about the spins of other galaxies. There is already a graphic demonstration of how I think the universe formed but they think it is only dark matter that follows this pattern. This link at 11 minutes 30 seconds for about 30 to 40 seconds shows how I see all the energy and matter in the universe over time, not just dark matter as they suggest in the video. There's a link there. There are also unanswered questions in quantum physics that could use some oversight. How do they keep an isolated electron from decaying long enough to shoot it at a pair of slits and detect it afterwards? What are the dimensions of the slits in comparison to the electron? It is, sign the date, 2018-06-06, Fencewalker Archimedes, your friendly neighborhood brain tumor survivor since 1990.